Hi, everyone. Thank you so much for being here. My name is Donna. I'm an Applied AI leader at Google, and I will be moderating today's panel on scaling Gemini with proven practices. On our panel, we have three incredible leaders and experts, Arka from DeepMind, Nick from JetBrains, and Naren from Roblox. So with that, let's start off with brief introductions. Can each of you tell us a little bit more about the company that you work for and your role? Arka, let's start with you.
I work for DeepMind, so I think Google DeepMind. I lead the Applied AI group at DeepMind, so I work with a lot of enterprises and governments, helping them get the most out of our models.
Sure. Well, good morning, everyone. Thanks for coming to us and not to developer keynote. I'm Nick from JetBrains. I'm working on Gemini, our AI development agent. You most likely know JetBrains if you're in software engineering. That's a company behind Kotlin, behind IntelliJ, PyCharm, and many other IDEs for professional development. And with Gemini, we utilize the power of those IDEs to apply it to agentic workflows.
Hey, folks. I'm Naren Koneru. I lead engineering for safety at Roblox. You probably know about Roblox if you have some kids, right? We are the largest gaming platform on the world, probably. We get around 150 million users. Our mission is to keep the environment safe for everybody. Yeah, I've been there just over 5 years, and before that, I spent a good 20 years in large-scale distributed systems.
All right, so let's start with how are you using Gemini in your organization? Naren, would you like to go first?
Yeah, if you think about Roblox, we are building games, or we are building a platform where people can come and build games. And it is 100% user-generated content, right? And our content ranges from a text to an image to a video to a 3D environment like this. And how do we make sure that all of this is safe, right? And our systems operate around anywhere from 1,000 requests per second to 700K requests per second. So we have to build any of these models with latency in mind, of course, cost because of the scale as well. And where Gemini comes in is we have a variety of these models, right? Some are built in-house. They're super special models that are really good at what they do. But sometimes, for the ambiguous things, they can't make these decisions. So we almost always have like a high recall and a high precision model. So we start with our own specialized models. They can make all the confident decisions that they can. And when they're unsure, that's when we send them to Gemini. And we use it for a variety of these models, right? Like for text as well as videos as well. And we can talk more about the use cases later.
Yeah. Nick?
Sure. Yeah. In Gemini, we have the development agentic case. And most of you familiar that Gemini Pro is a great model for development. But in our case, we actually selected Gemini Flash as our default model. And the reason for that is it really stands out as the quality to cost ratio. We really think it's the best model right now on the market. We've been able to get great results with it this year. Like on 2 benchmarks, on terminal benchmark, we got the 2nd place with Gemini Flash. And on SW Rebench, which is the Nebius bench for software development agents, we've been able to get pretty much on par results with Claude Code on Opus 4.6, while we've been running on Gemini Flash. And because we've been using different models, we had like 10 times different costs per task. So that was pretty impressive, and we're really happy about that.
That's great. Arka.
I'll talk about how we use Gemini at DeepMind or in my team. So when you think about an applied organization, pretty much every one of us, we are engineers or researchers with not really an industry-specific background. Like we have been working in software engineering or research. But now we have to work with experts like these guys who actually understand their industry inside out, and we don't. So throughout the entire kind of workflow of understanding the industry, the problem, like your technical base, the problem that you're trying to solve, all the way kind of figuring out the PRD that has to be put together for my engineering team, like Gemini and our models are really a great partner. We often end up in meetings where we get interesting terms thrown at us. Like I very recently learned about this concept of block trade, which are $500 million trades that happen every day. And I had no idea that it defines pretty much every macroeconomics indicators that exist. Like it impacts us, and I had no idea about it. And Gemini was a really good partner helping us break down what block trade is, what are the inefficiencies in that system, and also like as a brainstorming partner on how we can actually leverage large language models to making the right bets. I want to give like actual one interesting example. One of my colleagues in my team, he built this user simulator. And the idea was, I'm not going to use the word annoyed, but I keep asking him to do a ton of user studies. He does a ton of user studies. I keep asking him for more. So he ended up designing this system where you can give the model a personality very quickly and all the marketing attribution. So, really defining the model's cohort, and you're able to get this model to give you feedback on a product strategy that you're building. And it's almost like a synthetic user study that you can do to validate some of the learnings you have from the market. So really across the board, all the way through engineering as well, we are using our models for code gen, vulnerability detection, kind of figuring out bugs, making systems more efficient. Yeah, across the board.
Yeah, okay, great variety of different applications. So as you moved from pilot to production, what are some of the engineering constraints that you faced, and how did you overcome them? Nick, let's start with you.
Sure. So I think, again, the agentic projects are very different from your traditional software. And in traditional software, you have kind of a clear scope and clear use cases. And the moment you kind of implement it and cover these use cases with tests, you're kind of done. And that's not really the case with agentic software because we have much more complexity. We have different behavior for different models. We have different behavior for different prompts and instructions, and that's a very different game. So I think our way to deal with these constraints was really augment our team with the research team, with ML specialists, who really help us to do a lot of insights into how the model actually performs, not just the bare results in terms of this benchmark get so many % of the successful cases or what, but really go deeper, look at the trajectories, looking at the model behavior, look into inference time, number of steps, input and output tokens. So really go deeper in that. And really that's, I think, the reason which we've been able to succeed on those benchmarks, because we're not just implementing one prompt and forget about it. We really run the system which optimize how we work with that.
Yeah. Naren?
Yeah, I think going from a POC to production is really hard. I want to tell you guys a story, right? So in Roblox, we have this thing called a text filter, where you can type in any sentence that you want, but we don't let you swear on the platform. You can't bully people. You can't harass people. You can't share PII and things like that, right? So it has to work in real time. And of course, there are false positives, and there are misses. So I built this prototype over Thanksgiving break to say, can we leverage Gemini for unsure cases, and how well can we do better, right? And I was able to build it over the Thanksgiving break in like 3-4 days. I took it to my team, and I was so excited about it, like, let's ship this next week. And they just broke it in like 2 hours, right? And then we had to throw everything away and start from scratch, and then we were able to ship it in a couple of months. But then here's the 4 concrete things that I'd say. When we are shipping anything at scale, we first need to know how well the model is performing, right? And there are going to be metrics that you need to measure yourself on. We measure on recall and false positive rate, right? So we have to really do that. And then the challenge with large models, either Gemini or any of the state-of-the-art models, is you can make the prompt very broad. That'll give you really good recall, but also it'll hallucinate like hell, right? And the false positives just increase, and we can't afford that, right? That just the user experience suffers. So that's the first constraint on how do you make sure that your prompt tuning is still an art. We get a lot of help from from the DeepMind teams to help us tune the prompts better. It's still an art to get to really very, very high levels of precision. And once you're done with that, latency, availability is also important, right? Because we don't want the system to ever go down. And making sure that, okay, how do you test it? How do you load test it? How do you stress test it? And what are the latencies? Our latency used to be, a P90 was like 30 milliseconds. And because we introduced Gemini, our P90 went to a second, which we could afford in this case, but it is going to increase. And is that good for you or not? I think it depends on the use case, right? And our P75 is still 300 milliseconds because we still use our models for majority of our decisions. So that's the latency. And finally, cost matters as well, right? And we have to be very, like if we send all of our traffic to Gemini, we won't make any money. I mean, we won't have enough money to pay for Gemini. So we have to manage that as well, right? So those are the 4 metrics that we always look for, and being very diligent about measuring it and optimizing every single step of the way. That's the hard work, right? The initial prototypes are easy. You can impress everybody with these large models, but taking it to production is really hard.
Yeah. Arka, what are some other best practices you've seen with other customers?
So I'll start with saying this. I think, look, the technology is fairly new. It's still new. A lot of the scaffolding is still maturing around these systems, right? So, and us, all the labs, we are not going any slower in getting newer models with newer capabilities out into the market. So I think that presents almost like this perfect storm. And then along with this perfect storm, you have this incredible agentic coding systems that allows you to have a proliferation of MVPs within your organization. And we want to encourage that as well. But to get this MVP to production ready, to what Nick and Naren was saying, like you need a lot of observability systems. You need to be able to measure drift well, ensuring the uptime that you're actually promising your customers. You're able to manage that. You're able to, like when things actually go wrong, you are able to do your due diligence very quickly, find the root cause, and be able to land a patch. And if you find something that is actually off with the model, then you can't just patch it, right? So I think there are all these kind of lessons that we're learning, but I'm quite excited to see, like at GDM and at Cloud, we're making a ton of investments on those layers as well, everything from Vertex to the different kind of serving platforms we have. So I don't want to say that it's on any organization. I think it's really the lack of the maturity of the scaffolding that is causing a lot of the stress from going to pilot to production. And as those best practices get implemented through systems, which is the best way of doing it, that is getting solved quite significantly. We're getting much better at migration. Donna and I got to manage a bunch of customers migrating from 1.5 to 2.0. I think we both aged 20, 30 years through that process. But then when we look at 2.0 to 3, it's a very different experience. So I think things are definitely maturing, but it's not been straightforward.
Yeah. We touched on this a little bit already. We know that academic benchmarks, they don't reflect real world ROI. Can you share your framework for how you think about evaluation? Naren, let's start with you.
Yeah, I think when you're evaluating any model, whenever you look at the metrics, they're all gameable, right? I think the metrics are just a function of how hard your evaluation set is. So we need to keep building this eval set that is really, really hard, and then measure the model performance on it, right? As an example, yesterday there was a privacy model that was out there. Somebody released it. And immediately, I got like 50 pings from people saying, "Hey, there's this amazing model. How does it perform?" And we were able to run the eval set, and the recall was like 20%, right? But again, building the eval set is really the hardest one, and we do it in like 3 phases, if you will, in terms of measurement. We have an offline eval set, right? So that's what we measure our models on before we launch anything in production, anything in shadow, and this offline eval set gets better and better every day. And a really good function of this offline eval set getting harder is the existing model should be performing worse and worse every day as the eval set gets better, right? So that's a really good principle to have. And if not, you're just not trying hard enough to build the eval set. So that's what we build as an offline eval set, and we evaluate our models on that before we put it into production. But once you put it in production, especially in safety, it's adversarial, right? People change behaviors. And how do we adapt to those changing behaviors? And this is where we have a combination of sampling the production data, if you will, right? And then use that to sample the production data in like different kinds of samplers, right? You can't just take a random sample that won't be representative of the bypasses. So we have to use different techniques to sample the right data, use a combination of humans and LLMs to label it properly, and then really assess what the performance is. On top of that, we also build a bunch of AI agents to go and try to break our systems on a continuous basis online, right, based on what you're seeing. And that gives us yet another sample data. And that's how we measure it, right? And there's always going to be that the model's performance on the offline will look really good because that's what, otherwise we wouldn't launch it. And the online will look bad. And then we measure the threshold in which we set a threshold saying, hey, if the online is less than, let's say, 5%, 10% worse, it's time to deploy a new model with the new data, right? So that's kind of the framework that we have. And of course, you have to combine this with some kind of a qualitative measure of how users are actually feeling about this model, right? And that's where you need to get some real world use cases and have some people try this out to say, how long does it really take for someone to swear on a platform, right? And so those are the three frameworks that we use to measure the performance of the overall system.
How do you do it at JetBrains?
Sure. Well, in our use case, ideal scenario will be if we will be able to measure it, let's say, from the Jira ticket all the way to pull requests, but we don't always have this data. Our approach is very similar to what Naren described. We start with offline evals. We maintain the list of evals, and we constantly extend it with either vendor data, with our own research data. And then we also have a public benchmark, public data set. We call it Developer Productivity AI Arena. And we use this benchmark to measure essentially all the agents which are accessible within JetBrains IDs to select the best one. But in addition to offline evals, we have, when we deploy the new harness, the new version of our agent with a model, obviously there is data from user sentiment, and we have EAP program where we actively collaborate with users. We can ask them to look at the specific functionality. They give us feedback, whether something degrades, whether something gets better. We ourselves use our own agent. We use Juni to write Juni, so we have first-hand experience with how the model and the harness behave. And then you have, since we have a special situation in that case, that our software, our agent is being shipped to the users, and we adhere to zero data retention for many of the tracks there. So we have to kind of infer signals from user behavior without storing any of the data. So we can look at if our agent made a suggestion, did the user accept the suggestion, or did they kind of skipped it or edited it? If user, for example, reverted the changes of the file, that also gives us some indication about the success. And the last part, for small part of our early access program users, we do get the trajectories, and we use this data in order to be able to improve our benchmarks further. So it becomes the kind of the closed loop of this to improve that.
Yeah. Arka, what's your?
Yeah, you see, like I spend so much time thinking about academic benchmarks, so I don't want to like completely dismiss them. So I'm going to say a few things for them and then against them. I think academic benchmarks are very important for research to make sure our models are improving on a single axis, right? So, for example, if you want Gemini to be really good at looking through huge amounts of data in its uploaded context and be able to answer questions, like the multi-needle QA eval becomes very, very important for us to like individually track, manage, and get better at. But it's also absolutely true to say that those benchmarks do not necessarily reflect the complexity of an actual enterprise within which these models are getting deployed. Like a very anecdotal thing to say would be, like if you look at how we manage performance of us humans working in organizations, we have kind of perfected the art of doing performance reviews over decades and decades at organizations. And now we are having to figure out how to do that for all these like agentic colleagues who we are going to have in our organizations. And it's not straightforward. It's not straightforward because none of us write a prompt that is like testing the model on a single axis. Right? So you rarely will ever in production write a prompt which is going to be a perfect fit for tool use or a perfect fit for multi-needle QA. It's going to be always a very composite prompt that you write. And where the model might have to trigger the search API, it has to get those tokens in, reason on them, and then actually maybe do a tool call, and then do a summarization because you have a particular preference. And that's where we start seeing some failure cases where over-optimizing on a benchmark just doesn't work. The other interesting area is, like, I feel like since since internet proliferated, like the number of polymaths have gone down because you just know more, so you know that you know less. And I have a point to make here, sorry, just follow me. Polymaths have gone down, and what's happening now is you have this one model which is the entire complexity of world's information, right? So you're literally training a polymath which has a huge amount of chemical engineering understanding. It understands laws, it understands societal like behavioral finance. It has all this kind of information in there. So when you're writing a prompt, more often than not, it's going to kind of bleed into this common areas of knowledge. So it presents an even more difficult eval job on how do you get a human evaluator to first agree with the autorator you write, because this person might be an expert in finance but might not understand this amino acid chain you're talking about. So there are, and the pure synthetic strategy might just inflate whatever errors you have in the model that you're using to generate the synthetic data. So evals are hard, and no one has really solved it. We have made huge progress in getting this real world evaluations which are highly representative of what's happening in the enterprise, but we are a long way from any kind of perfection. But I think, especially in 2026, it really feels like the world is pivoting. Like even in organizations, we see that they're going beyond this well-known, documented, research-led academic benchmarks to creating evals which almost look like a representation of a product requirement doc at the company. So I think, like the faster we are able to generate this kind of high fidelity, high signal, very very high quality evals, which are like looking at it, a user just says these are the exact prompts that I write, and this is how I would evaluate. That's becoming very very important. It's not easy, but it is absolutely the P0 thing to do, to take anything to production. That's what helps you understand if you're drifting. I also wanted to give a huge plus 100 to what Naren was saying around the headroom has to be always there. The evals have to keep creeping up in complexity, because I feel like it's an inherent human nature. Like first we start talking about very simple things, and then we start talking about exceedingly more complex things. And that's going to continue. And as more complex tokens get loaded in the model's context window, the conversation just matures. So this creeping difficulty is very, very important to do. So it's never a one-time build it, ship it, eval. Yeah. It's an always improving flywheel is what you're trying to develop. And the closer to sampling your production data you are, the closer to reality your eval sets are.
Yeah, 100%. Like a year ago, we launched a model in the text domain. When we launched it on the eval set at that time, the offline eval set, our recall was like 98%, right? The same models recall on today's eval set is 20%, right? So it's like useless, that model. So but that's a function of how hard we are making these eval sets on every day.
Yeah, and that's not because Gemini kept getting better, but the eval got much harder, just to clarify.
So you talked a little bit about the flywheel. So Arka, how do you partner with customers to improve the quality of the model for the best customer outcomes?
Yeah, so the Applied team, we are organized by industries. And our mandate is kind of twofold. One is we are here to prove the stack to the to us and to making sure that it's actually adding a ton of value. What I mean by proving the stack is everything from, Google is really a full stack operation. We are everything. We're designing our own chips. We own our own data centers. We train our own models. We own the products through which these models are getting deployed. So we want to understand deeply what does it take for a deployment to be successful within an enterprise, to actually add the business ROI, and what are these missing links in this stack that will actually make it a whole lot easier. And we take that feedback and build better evaluating tools. A lot of inputs go back to Vertex. A lot of inputs go back to the modeling world. Maybe an example will be helpful. I'll go back to this block trade problem that I was talking about, where if you dump $500 million worth of stock in one go, you might trigger some circuit breakers, and you might destroy the market just a little bit. So a lot of financial organizations, they have to figure out the specific percentage of the average daily volume that they're allowed or that they should be selling or buying in the market. And it was predominantly run by, let's call them not so smart bots, so very, very deterministic bots which will look at the market. And we realized that some of the best humans who are doing this kind of work, their superpower is they're able to parse through huge amounts of data from different sources, everything from public sources like the internet, their local corpus, able to understand other behaviors that was instituted within the organization. And they use those data points to actually make this ADR, this percentage decision. This is not something that Google or DeepMind would ever be thinking about or optimizing for. But it turns out that it really tests the model on some very specific capabilities, improving which actually makes our model horizontally better at a whole bunch of other use cases. So our team really works with a lot of organizations in the gaming industry, in finance, banking, insurance, retail, and all the way through public sector to understand what it takes for these models to be successful within this enterprise's installed base, and then bringing a lot of that insight back to cloud and GDM to build this flywheel of improvement.
Yeah. So we talked about evaluation, we talked about pilot to production, the feedback loop. Let's move to scaling production workloads. So maybe Nick, let's start with you. What did you learn from moving to 100 to thousands to millions of users?
Sure. Well, first of all, I think once we get to the real production use, it becomes, beside all the challenges of evaluations, which we already covered, the other part, I think it was partially touched by Naren already, is being able to predict and manage your workload and the consumption of tokens, because the hardware is limited, and you can, to a degree, forecast what will be the consumption. There is certain patterns, cyclicality within the day or day of the week, but it's still very hard. So the best scenario is really to monitor your real workloads and monitor your API responses. You really don't want to get to rate limit errors. So you need to make sure that you proactively update your throughput provisions, and we've been very happy with our collaboration with our Google partners to find solutions there which are cost efficient and which allow us to both move, scale, and at the same time not to burn the hole in this process. Yeah, yeah. And I wanted to chat actually on the thing which Arka said about the working with the customers. We've seen a lot of support from Google Cloud team. We honored to be part of the early access program and work with alpha versions of the models and provide feedback. I think that's really helped us to actually improve the Gemini Flash performance. And I think some of our comments even postponed the release of Gemini Pro for a week. So well done. Yeah. Yeah,
and very valuable for us as well. Naren, do you have any thoughts on scaling?
Before I talk about the scaling production workloads, just piggybacking on what Arka said, the industry is moving at such a rapid pace, right? So that there are new models out there all the time, and whenever there is a new version of any of the state-of-the-art models, when we try to adopt it, we have to assume that, okay, the model is getting better every day, but that's not always the case, right? And this is statistics, it's not deterministic, so the models can hallucinate and stuff. And sometimes we do see that the new versions actually perform worse on our existing sets. But I think that's something that we have to, the only way to know is having a very robust evaluation set, right? If you don't have a robust evaluation set, if you don't have a way to measure this continuously and be in a day, you can get the results, then it's really hard because I think the industry is just changing and you just don't know which one is the right thing to do, right thing to use, right? So, and that's part of moving stuff into production as well, right? Like when you are in production and there is something new out there that you want to go try it out, you need to have a really good observability platform. You need to have a good experimentation platform so that you can actually start testing this live in production as well, right? Provisioning and throughput was a big deal. I mean, when we were launching this in production, we did our math wrong in terms of how many servers we actually need, and then that cost us an outage, right? And those are things that we need to be really, really careful about. And especially when you're trying to serve it over 100 million users, and between 10 to 20 million QPS of some of the services, so these things become even harder and harder, right? Now, one example, one concrete example that we can talk about when we were starting using Gemini is it's just the shape of the workload also will determine the throughput, right? So our shape of the workload is mostly we give a long sequence, but the output is just a classification, right? We just want to know which policy it's violating, which is very different than a typical Gemini use case where it's a very generative model, right? And that just pre-filled all the buffers, and our latencies just started spiking when we started provisioning on Google Cloud. But that's something that we were able to work with the team to get through. But again, having that framework of launching it in production in shadow, so that you can recover from failures easily. So those are some of the things that we need to build as an infrastructure before we can go all in.
Yeah, that makes sense. Diving a little bit into monitoring, how are you monitoring your production workloads, and what advice would you have for the audience?
Yeah, so I mentioned the metrics that we talked about in the past, right? So the latency, the availability, recall, and false positive rates. And for latency and availability, we just get like live charts and we have alerts, right? If something goes on, my PagerDuty may just go off right now, right? So but then the recall and the false positive metrics, we get that on a daily basis, right? So those are the 4 metrics that we typically watch out every day. The last one I would say is also important is the cost, right? And something maybe a spicy take, but sometimes the cost just goes up, right? With the new version of the model. What's happening with that, Arka? And in that case, we have to go back to our first principles and really think about how to deal with it, right? Because we all have a budget to manage as well, and we also need to think through it. So we're not too worried about costs on a daily basis, but that's something that we constantly keep an eye on. But the other 4 are live in seconds. We need to know what those metrics are.
Yeah. Nick?
Sure. I think I'm very much aligned here with Naren in terms of measuring the latency and availability. For us, we also do measure the response of APIs, and we actually had to implement even the measures to be able to do a quick switch, the model routing where some availability of the models are lacking or we hit in the rate limits. But the rest of the things, as I mentioned, also important for us. The signals which I mentioned on the eval side really telling for us if the users are switching the model, something is not right. So that's also a great indicator to follow up on.
Yeah.
Yeah, I was just going to say, I really like that. So I think it's really the whole system monitoring, right? Like the whole solution monitoring is not just running the evals on the model. It's the telemetry to the entire product's performance, efficiency, latency goals that you have, and if there is any kind of drift. What I've also seen is always a combination of things where I've even seen companies do a fixed percentage of production data gets sampled, goes through a human labeling process to kind of see if it's agreeing with the standards they have set for themselves. And they use that data to then train an autorator to automate so that they can sample more of the production data, all the way through to LLM-powered unit tests as well for edge cases which a user might have given some kind of a signal towards, either through like a thumbs down or something like that. So it's really a combination of tooling that is often used, right, to be monitoring production workloads. I feel like just in the last 18 months, like huge progress has happened in monitoring production workloads. But yeah, that would be it.
Yeah, definitely. Okay, we will now open the floor to audience questions. So if you have a question that you would like to ask, please raise your hand, and there are mic runners that will run to you.
It's way too early in the morning.
There's a question? Yeah.
Hi, everybody. Thanks for the session. Gadi, CEO of Bright Security. You talked a lot about scalability and different aspects of testing. What about the security aspect? You didn't touch on that.
Yeah, great question. Who would like to touch on that?
Yeah, I would answer it like everything that we talked about is inside the security bubble. So I think like we're engulfed in any system that we design. It goes through significant testing for any kind of readiness, and I think to your point is becoming abundantly clear that establishing your security controls and having the same kind of telemetry into system performance is becoming even more important. So sorry if we didn't bring that topic up, but that's kind of like the surface on which all of this is sitting. It's very, very important. Yeah.
I actually have something to build up on what Arka said. Like in our case, for example, there is a lot of situation where agentic development is being constantly augmented with a different skill set, with external kind of prompt collections which users add in order to work with a specific projects. And that has inherent risk of prompt injections, which might be introduced. So having a special monitoring between the agents and between models is super important. We do have some experience with that.
Yeah, I will also add like a ton of red teaming is often done to any kind of solution before it ends up in the market. And then you have special classifiers that you are training and running on your production workload just to kind of track different behaviors that you want to be able to flag and take into account. But I think it's a very important topic. Thanks for flagging it.
Yeah, it is top of mind, and that's one of the reasons why our velocity could also be lower. But I think it is important, and unless we feel really, really secure, we can deploy it. And some of the techniques that we use is to make sure that we have enough protections against the jailbreaking, like prompt injections, but also try to put them in like sandbox environments, these agents, so that they have limited access to the systems. But yeah, I mean it's top of mind for before deploying any workload.
Yeah.
Thank you. My name is Ravinder. I'm a principal architect with Tech Mahindra. I have a question that do we have a single pane of glass for our observability? Does this exist? If not, what different tools, leading tools that you guys use?
I mean, I'll tell you how we do it at Roblox. We developed a single pane of glass, but that's like with a combination of both the in-house tools as well as a bunch of open source tools that we use. Right, like Grafana is the one that we use to monitor all of our production service workloads. But then for internal eval sets, how they're performing, how they're continuously getting harder and harder, this is something we developed in-house, and that's what we use, right? I don't know if there is a single tool out there to get all the observability of all the models. Maybe there is out there, but for us, what we see is anytime we try to adopt any vendor-specific things that typically don't scale at for our workloads, so we end up developing most of this in-house.
Yeah, I think that's a real challenge in it because there is no ready-for-use tool because this problem didn't exist in the 16 months before. And in our case, we started to make our own tool for that. And this year, about a month ago, we even productized it. We call it JetBrains Central, which is basically a monitoring system and an analytics system on top of all your models consumption, which serve exactly that point to provide the observability for that.
Hi, it's Eric here from Vitality in the Discovery Group in South Africa. Just wanted to ask for smaller teams, when you speak about observability, evals, you know, when you don't have many people working on all of these different functions, how to make that trade-off well if you've got a smaller team of 4 or 5 technical people working on a solution that's going to production?
Yeah, I can take a stab at it. I would say, you know, this might be a controversial thing to say, but instead of focusing on a PRD, get them to write eval sets to kind of describe the product. I think just having a set of evals which represent your use case is the P0 requirement. That should be the starting point of anything and everything you do, all the way from, like, you know, you're making your model selection decision, having some highly curated evals that help you through the development process and then to production. So I would just kind of map out the right evals that you need through the development journey. And I think there are a ton of best practices now on how to scale eval data generation methods. There's a lot of research that has already happened. There's good tooling available at Google and outside of Google to help you do that. And I think there are sufficiently, you know, the right-sized model where you can have a human maybe produce even 50 examples that you can then synthetically explode to a more statistically significant eval set. But I would just bring a lot of centricity on evals defining the product that you're trying to build.
Yeah, very much agree with Arka on that. If you have a small team, obviously we have a luxury of doing the research and testing and finding the best sweet spot in terms of efficiency. But yeah, teams don't always have that. Having evals and using structured outputs from the models will basically make your baseline. Yes, maybe you could do some evaluation with that and do some research with that and optimize it, but if you don't have a budget for that, you already have a working solution if it solves the evaluation which you have.
Yeah, the only thing to add there is I think small teams is actually becoming an advantage as opposed to the other way around, right? In fact, I think some of the recent projects that we've been doing, we're trying to always find the smallest number of people that we can get this project with, and typically what we find is the sweet spot is between 4 to 6 people that are involved. You know, we just lock them up in a room and, you know, they'll come up with some magic in a week. You know, that's been kind of the principle we've been going by.
Yeah, that's such a good point. Like, you will reach consensus on what eval to build way faster than many others who are larger.
Mm.
Yeah.
All right, I think with that we are actually at time. So thank you so much for joining this panel and all the great insights on evaluation, moving from pilot to production and scaling. For developers in the audience that are interested in learning more about building, deploying, and scaling agents with Gemini and Agent Platform, you can check out our Gemini Enterprise Agent Ready learning program. We also welcome any feedback on this session. Please do complete the survey. And thank you again. We'll be around for any questions.
Thank you.